Hello, PreCalc students. Today we are going to do a third day of the hyperbola, and this is our last day of the hyperbola and our last day in the unit. So great job getting through this unit. I think you guys are really learning despite the unusual circumstances, so nice job on all your efforts. Today I'm going to give you 3 pieces of information, and you're going to write me the equation and finish the graph. Okay? All right, so it says that there's a hyperbola with a focus at -4, 0. So let me graph. Hold on. I got some pens. Okay, so I'm going to plot everything in green that I was given. So -4, 0. 1, 2, 3, 4. Okay, and then there's a vertice at -4, 4. 1, 2, 3, 4. I'm going to mark that. And there is a vertice at -4, 2. Okay, so that's all the stuff that was given. Okay, now what I'm going to do is I'm going to add all the stuff that we know. Okay, so for instance, we know that if there's a vertex here and a vertex here, then there has to be a center right here. Okay, because the center has to be symmetrical. So let's go ahead and just write down that we know the center now. The center is -4, 3. Okay. All right, if there's a focus 1, 2, 3 down from the center, then there's a focus 1, 2, 3 up. So there's a focus right here. Okay. So the only thing we actually don't know is the width of our box. Okay, we know that this hyperbola goes like this because that's a vertice. So the hyperbola goes like this and it goes like this. Okay, so if you remember, if I just sketch this, if we have a hyperbola that goes like this and like this is parallel to the y-axis. So now you know that the y term is going to be first and the y term is going to be positive. And since we have the center, we can go ahead and fill in the whole top. So y minus 3 squared minus, don't forget that, x plus 4 squared equals 1. Okay, so again, we know this is first and this is positive because the vertices are in the parallel to the y-axis. Okay, so if you look at our picture, underneath the y is like the distance from the center to the vertex because it's the height of the box. So this right here is the height of the box in the y direction. We know that, it's 1. Okay, what we don't know is how far out I'm going to draw my box. Okay, so this is what we do know. We know the distance to the foci is 3. We know the distance to the vertex is 1. So we're just going to use that equation to find this, which is the width of the box. Okay, so 9 equals 1 plus b squared. 8 equals b squared. Square root of 8 equals b, which of course is 2 root 2. Okay, so now I know that from the center, okay, because this is the x direction, I'm going to go out root 8, which is just less than 3, out root 8, 1, 2, which is just less than 3, and then I'm going to draw my box. Okay, I'm going to draw asymptotes through my box, through the center. 1, 2, 3. Oh, I went out a little too far, you guys, sorry. Let me erase, hold on. Let me get my correction tape. I can tell because it just wasn't symmetrical. There we go, that looks better. Okay, and then we go through the box like this. Okay, and then don't forget to actually draw. Okay, so when you draw it, you go closer to the asymptotes, through the vertex, up. Okay, and then stick close to those asymptotes, through the vertex, and out. So that pink thing is my actual hyperbola. The foci are outside of it. Okay, so let's finish our equation. The equation underneath here is always b squared, which is already here, so that's 8. So there's our equation. Okay, and then the foci are at really nice points, so I don't have to add those, but I do have to add the equation of the asymptotes. Remember, that's y minus k equals plus or minus m x minus h, where h and k are the center. So we have my y minus 3. And then the slope is rise, which is 1, run, which is root 8 or 2 root 2. So 1 over 2 root 2, x plus 4. Okay, I do want you to rationalize this. So if you multiply that by root 2, top and bottom, you get root 2 over 4. x plus 4. Okay, all right. So we're going to do one more example, okay? In this example, I gave you, hold on, let me flip, oh dear. See if I can reuse that tape. Hold on. Okay, there we go. Okay, so in this example, I'm giving you the vertices and an asymptote, okay? So let's plot the things that I know. I know the vertices are -1, and 3, -1. Okay, vertice, vertice. So already what I know is that my hyperbola opens this way, okay? So that's parallel to the x-axis, so I know that the x is positive and the x is first, okay? Because the hyperbola is going to go like this, and it's going to go like this, okay? Because that's what the vertices mean, okay? All right, and I also can find my center, okay? Because the center has to be right in the middle, so now I know my center, okay, is 1, -1, okay? All right. They don't give you any other piece of information, but they do give you the asymptote. And if you notice, this 1, -1 is the center, which we knew. And then this says it has a slope of 3/2, which basically gives you not only the height, but the width of the box, okay? Up 3/2, negative, because this is just one asymptote. There's also one with a negative. Down 3/2, and down 3/2. Geez, I keep counting wrong today. There's something wrong with me. There we go. Okay. So from the center, since we know the slope of the asymptote is 3/2, I went up 3/2, up 3/2, down 3/2, down 3/2. Okay. Sorry, I've been doing some painting, so there's paint on my finger. All right, and then you draw the box like this. Okay, you draw the asymptotes through the box. Okay. We already knew that the vertices make it open sideways. So you know that the hyperbola opens this way, and it opens this way. Okay, so we have our graph. We need our equation. We already have the equation of the asymptotes. You can just add a plus or minus there to get both of them. Okay, so we need the foci and we need the equation. Okay, so let's just write the equation first because you have all the information you need for that. Okay, so because it opens in this direction, you know x is first. Okay, and it goes through the center. So the center is right there. So it's going to be x minus 1 squared minus y plus 1 squared equals 1. Okay, in the x direction, from the center you go out 2. So you square that, you get 4. In the y direction, you go up 3. So you square that and you get 9. Okay, so this determines the width of the box. This determines the height of the box from the center. Okay. Remember the foci is always the big one. So c squared equals a squared plus b squared. This is a and b. Doesn't matter which one's which. So c squared equals 13. So c equals the square root of 13. So from the center, you're going to go out the square root of 13, which is about 3.5-ish. So 1, 2, 3.5. And 1, 2, 3.5. Okay, and I do want you to tell me those exact points. Okay, so from the center, which is at 1, you're going to add root 13 and go down 1. Okay, here from the center, which is at 1, you're going to, oh dear, like over, definitely using this tape today. Okay, 1 minus root 13 minus 1. So that's the foci. All right, so that wraps up hyperbolas. Remember, we do have an optional Zoom meeting tomorrow where we're just gonna kind of check in. I can see your faces, and you guys can ask general questions, math questions. I just kind of wanna see how the format works. So I don't know if it's gonna be good for teaching per se, but I just wanna check it out. And I thought you guys would be a good group to just experiment with it. So I said first and fourth period has one time, fifth and sixth period has a different time. But obviously, if you can't make the one you're supposed to go to and you want to come, just come to the other one. I only did that to split it up so I wouldn't have 110 of you in one Zoom. All right, so hopefully I'll see you guys tomorrow. Take care. Bye.